Okay, so let me start. Uh, we go to chapter 3 about general tensors. There are a number of continuum mechanics books in the literature written with the general tensor formulation. An essential characteristics of general tensors is the use of curvilinear coordinate. We may imagine a Cartesian grid placed inside a continuum. As a continuum deforms, the grid lines deform with it into a mesh of curves. Thus, general tensors formulations are convenient to describe continuum mechanics. Although this chapter is not required to follow our presentation of continuum mechanics in terms of Cartesian tensors, it will be of value to extend the student's knowledge through additional reading. In modern computational mechanics, curvilinear grids are often used, and the governing equation in general tensor formulation are needed. In modern computational mechanics, curvilinear grids are often used, and the governing equation in general tensor formulation are needed. As an added bonus, students will be able to follow the theory of shells and the general theory of relativities. Theory of shells. なんだろうね、これ。What is theory of shells? Theory of shells. Theory of shells. シェル理論。Anyway, theory of shell and general theory of relativity. In the previous chapter, we saw systems of Cartesian coordinates and transformation of tensors between two coordinates that are related linearly. When we have to deal with curvilinear coordinates, the coordinate transformations are in general nonlinear, and the coordinates may not form an orthogonal system. Representation of tensors in such a system depends on the direction of local tangent and normals to the coordinate surfaces. It is conventional to use superscript to denote the coordinate curves. The reason for this will be clarified later. Let us begin with the Cartesian system with labels x1, x2, and x3 transforming into curvilinear system xi1, xi2, and xi3. A two-dimensional illustration of this is shown in figure 3.1. We assume that the relation between xi and xij, xij or xij and its inverse. Locally one-to-one. What is meant by locally one-to-one is that in the neighborhood of a point xi1, xi2, xi3, the increments dxi of the coordinates xi are linearly related to the increments xij, d xij of xij, and these relations can be inverted. It's a little bit complicated. Distance element. Distance element. Anyway, we have dxi, partial xi, partial xij, d xij. This is summation convention here. Summation convention. And the matrix L means LJI, partial xi, partial xij, which is evaluated at specific point of xi1, xi2, xi3 is non-singular. Matrix L is non-singular. This is non-singular. We use the notation L is determinant Lij. Referring to figure 3.1, the distance vector OC can be expressed in terms of the increments in the Cartesian coordinates dxi as well as in terms of the increments in the curvilinear coordinate dxi. This guy. With OA G1 xi D xi1 D xi1. See, this is D xi1 D xi1. And this is D xi2 D xi2. OA OB OA OB D xi. So this is a question. OA OB D xi1. We have the vector sum. From this, the vector base vector. From this, the base vector gi can be related to the Cartesian base vectors ei. Okay. This is basis vector. This is a base vector. This is base vector. 惜しい。惜しい。つまりどういう意味？dx1 e1 plus dx2 e2 plus dx3 e3 equal g1 dxi1 plus g2 dxi2 plus g3 dxi3. So this here, I think, because this is partial derivative, xi2 and xi3 are fixed to constant. Yeah. So these things are fixed to constant. Okay, so then we take a partial derivative of this with respect to this. You take a partial derivative of this with respect to this. Take partial derivative of this with respect to this. That's this. So this is also a summation convention. Here, this is summation. Summation convention. This is summation convention. Okay. The base vector gi is tangential to the curve xi. Here, the curve xi1 refers to the curve along which xi1 changes while xi2 and xi3 remains constant. Unlike Cartesian coordinates, curvilinear coordinates may not have the dimension of length. This is interesting. Unlike Cartesian coordinates, the curvilinear coordinates may not have the dimension of length. As an example, we use angles as coordinates in polar and spherical system. The term gi d xi must have the dimension of length, and if d xi is non-dimensional, gi has the dimension of length. In general, I don't understand this. Why does he say this? As an example, we use angles as coordinates in polar and spherical systems. 私。As an example, we use angles as coordinates in polar and spherical systems. The term something must have the dimension of length. And if d xi is non-dimensional, gi has the dimension of length. In general, then all the gi may not have the same dimensions and they are not unit vectors. The distance between O and sigma c can be expressed in terms in the form. Just a second, I just need something to do. Okay, sorry, I had to fix my condition of my throat. The term may not have the same dimension, and they are not unit vectors. The distance between O and C can be expressed in the form Gij, d xi I, d xi j, gij, interesting. What is the original definition of G? G, this is the original definition. Right? Interesting. JJ, JJ, JJ sigma I. Shall I use whiteboard maybe? Let me see. GI. Okay. GI is J X I E J. Is this correct? XJ xi I. XJ xi I. This way. So then we also have GK, for example. X xi I J K L, maybe X L E L xi K. Okay. So GI dotted with GK, which is the definition of GIK, is it called GIK? I forgot. Sorry. GIK. Yeah. So this GIK is like this. Partial XJ partial xi I EJ partial XL partial xi K EL. What about this? Then this guy EJ dotted with EL. This is delta JL. And you have a summation convention JL. And I have a little bit confused. Then you have sigma xj sigma xi I partial xl partial xi k then delta jl. Then maybe we apply summation convention to L part only. So then we will get partial xj partial xi I partial xj partial xi k. That's the end formula. Yeah, this is this part. So we obtained this one. Then question is how we obtain this one. L is this x xi. Okay, this one. This is L kj. This one L ki. Yeah. So we can make this one. This guy's transverse. Then jk. This is jk. Let me see. Okay, let me xk xi. This is like this. xk xi and xk xij. xk xij, right? So this can be written as this L Ki, I think. According to the definition, let's see, what is the definition? This one, Ji. Okay, downstairs first. This is Jk. You can Ik. And the second one can be written as Jk. So then you can make this guy. This guy is actually the same thing as L transpose Kj. Yeah. Then you have a summation convention here. So if you have a summation convention, this is just become matrix. This is matrix multiplication. So that means L, LT, IJ. So you can have this LLT. Because you remember, you should remember this. If this is a matrix, if A is B multiplied by C, then this component ij can be written as this bik ckj. See, this is same. This is worth remembering. See, you have this in between. You have k for summation convention. Yeah? So the same rule apply here. So this k in between is the summation convention for matrix multiplication, right? So I think this is clear. The elements Gij are called the components of Riemann metric tensor G associated with the curvilinear system. In the distance formula, when a Cartesian system is used, we have the Euclidean distance measure dxk, and when the curvilinear system is used, we have a Riemann measure Gij d xi d xij. As mentioned earlier, G1 is the tangent to the coordinate curve sigma xi1, and G1 and G2 lie in the tangent plane of the surface formed by xi1 and xi2 curve. We can construct a normal G3 to this surface with its length adjusted to have G3 up subject, down subject equal 1. Completing this scheme, we obtain new vectors Gi up with the properties GI downloaded with GJ up is delta IJ, which is a Kronecker delta in the general tensor setting. In expanded form, this is a little bit strange. I have some doubt. I have some doubt here. Is this 0? Maybe we have to define G up in such a way. Yeah, okay. So this is definition. Okay. This is definition for G up. Like this, for example, 1, 2, 1, 2, 2, 3, 3. So this is more like definition. Definition for GI, up subscript. We call GI the covariant base vector, or simply base vector. GI up the contravariant base vector or reciprocal base vector, because GI up form normal vectors to the tangent plane. We have normal vector to the tangent plane. Where the constant of proportionality k is found from something. Let me see. What does this mean? We have strange. Let me see. Let me delete this. little bit complicated. So if you have like a G, this is like a G1. Then if you have, this is like a G2. And there's you have some plane. And this is like normal to this plane. This is called G up subscript. G3 up. Then the question is what is G? What is G3 down? Maybe we can do this way. For example, we can obtain from G1 and G2, we can get G3. Then we can get G1 up and G2 up. We can obtain G3 down. Is this the case? Maybe. We call GI the covariant base vector or simply base vector, and GI the contravariant base vector or reciprocal base vector, because GI up form normal vectors to the tangent planes. We have this is okay. This if we go, you can change G3 equal K, G1 cross G2. And this is just a definition of G3. This is just the definition of G3. And we just require same relation applied for permutated indices. So same relation, we require the same relation applied to the permutated indices like G1, G2, G3. So this holds. We accept this also hold. Where the constant of proportionality K is found from this. Yes. Yeah. as the scalar product or triple product of three vectors is invariant with respect to the permutations of the vectors, we find that the constant k given by something like this is invariant if we permute the integers in equation 313 base vectors complicated. Using the Cartesian representation of G1, Gi in equation 3.8, we find that the scalar product of the determinant L, let's see, it's complicated, right? So let me stop. Let me have a break here. So we start from, this is the page. We start from page 30. We start from page 30 next time. Okay, so what time is it? Start page 30. So this has some problem. So it already did 44 minutes.